My name is Aaron Mueller. I'm Principal Cloud Architect at Super League Gaming.
And I am Brandon Williams. I am the QA manager, software QA manager. It says senior QA manager, so distinguished.
This is Virtual Test Agents, building a better tomorrow with virtual people. So what are we going to talk about today? We built some pretty cool tech, or we definitely think it's some pretty cool tech at Super League Gaming, and we're going to talk about that tech. At the end, we're going to demo it, but realistically, this is going to talk about our journey, about how we got to this point. So we'll start out, we'll tell a little bit about who we are and what Super League Gaming is. We'll talk about like the old ways we did business. We'll talk about like the challenge that was posed to us, how we came up with a solution, and then we'll give you a demo.
All right, so at Super League Gaming, we're the world's premier platform for amateur gamers to experience their sports like the pros. So I like to refer to it as the little league of esports with big league technology. We provide a number of in-person experiences all over the country. We have 40 venues in 16 different cities that are constantly going. We can kind of see an example of one right here where we have about 60, 70 people playing League of Legends all at the same time in a tournament program that we offer. And as you see, we offer a lot of online matchmaking and tournaments across several different game titles and platforms like League of Legends, Minecraft, Fortnite, a number of them, right? So we're really trying to tap into that amateur esports market. Right here we have an example of one of the games that we offer. This is a Clash Royale. I'm not sure if anybody plays. But Aaron can kind of describe some of the stuff that's going on here since he built most of this technology that's powering this.
So this is all done in the cloud. So we have our visualization, we do gameplay capture, and all this other stuff inside AWS. And so there's a lot of like core AWS technologies we've leveraged to be able to build this, and we'll talk about that as this goes through. But realistically, at Super League, we build experiences, and right now we're building experiences to like build the platform to be able to build these experiences, and then we're using the platform internally. We're dogfooding it, and then we're releasing it out to ambassadors and key partners, so other people can build these esports experiences for themselves using the technology that we've built. And so this is actually one of our interfaces for our platform where we can spin up and run a Clash tournament internally, and so we can like configure the tournament to exactly how we want it to run and how many instances and cities and all the visualization that you see in the HUD, and then we can either have it run manually so somebody can dictate how it goes, or it can be run on Rails. So it just sort of like you set it and forget it.
Yeah, so when I joined Summit, we're a very small company based out of Santa Monica. We have a very, very small team. And as QA, one question, do we have any QA in the audience here? Raise your hand. Yeah. Oh, my goodness. Thank you.
Three more than you thought.
So we had a very heavy reliance on manual testing when I first started. So one of my first goals was to implement the standard automation stuff, right? So Selenium, basically tackling our core competencies, registrations, purchases, etc. But then we quickly hit a problem that parallelization in standard Selenium and workflows kind of couldn't really address, right? So right up here we have an example of what we call our online matchmaking system. And this requires a good deal of coordination from normal people, right? We might need upwards of 10 to 100 people to click a button all at the same time in order to do something like produce a tournament code from one of our publishers like Riot for League of Legends, for example.
So whenever you have a very complex problem, typically that problem gets assigned to humans. And so we definitely had humans tackling these problems and testing. And so this is an actual interface that we have that we can visualize the health of our online matchmaker, right? And so all these people come into a lobby, they get queued, they select a role, and then they get shipped into this like bus, and then the bus gets shipped into a confirmed state, and then when they all confirm, they get issued a tournament code. They can play a game, right? And so like there's like a high amount of concurrency and coordination that people go through, and then like feedback the system gives them that they have to react to actually like get a game started, which you'll see like up here. And so that's like that whole process. That's like one game being created, right?
So during my interview, the CTO asked if I would be willing to manage these large-scale game tests. Of course, being QA, I was like, yeah, why not, right? So we would reach out to the field, and we would hire anywhere between 30, 40 people, and be lucky if maybe 10 or 12 people showed up, right? So the human condition was really a major obstacle. Most of the people that showed up didn't show up in a testing mindset. Getting them to coordinate between activities that we needed to test them on, just to test whatever feature we were working on at that particular time, was a nightmare. I often use the analogy that it was like herding discombobulated cats, right? It took about a similar effort to do that. So it was generally a massive undertaking. I really did not enjoy it, so it was a unique challenge.
So our CTO says, Brandon, hey, love the work you've done. You've got a lot of automated testing on our website and all this other stuff, but like, what about automated end-to-end testing? What if we applied sort of this concept we have for like whenever we deployment and doing integration testing and all this other stuff, but like through all of it, through all this like coordinated, simultaneous actions that it takes to run our OMM, through like actual gameplay, to have the same sort of validation and regression, all these principles, but I don't want to use people. So Brandon came up with a first pass at this. He recorded this and he's kind enough to share it with us.
So I found a bunch of these laptops all around the office. You'll see some of them have like broken screens. They're pretty crap, right? These would be devices that we'd give to players that didn't have equipment if they came to play in one of our theater venues. And I implemented some keyboard and mouse broadcasting software, so I could basically control an array of computers with one keyboard and mouse. It was a nightmare. I was constantly up late at night till 2 or 3 in the morning running these tests, running from bay to bay, one bay for each team, and it was exhausting, to say the least.
So Brandon comes in one morning and he's exhausted, and I'm like, "What's up?" And he's telling me about this process, kind of shows it to me, and I'm like, "Brandon, we have tech in this company I have to introduce you to." And it was one of these moments where it was this aha moment that we had, right? And it's interesting and it's unique because we had this issue at Super League. So you guys are probably asking like, "Why are you guys at an AWS conference?" So when we were doing these events, we had like a very high amount of deployment, right? We had to go do site surveys, like drop internet. We had to like deploy laptops that could play games. We were hooking into projectors and TVs, right? And so I actually spent a lot of time coming in the company and doing a physical to virtual migration effectively of this stuff. And so I built this spectator client framework that allows us to run these games and do these visualizations inside AWS using GPU instances. And so like the framework is designed such as you could write very simple logic to like leverage the power of this framework, and we could control these machines that are like these virtual machines that we run the gameplay on, right? So I like introduced Brandon to this framework. So here's like kind of a diagram of how this looks like on a running state for an event, right? And so we have like a lot of microservices running in ECS clusters over here. We have like this HUD controller that allows like our visualization of the HUD. We do like actual full production services in the cloud. We have the spectator clients creating visualization, and all of that gets output, very low latency to users participating in these venues.
Yeah, so as I alluded to earlier, one of my big goals and challenges was, implementing early discovery process into our deployment pipeline. So this is kind of just a basic example. If you've worked in QA, you've seen 1,000. This was a relatively easy lift. So this is a basic framework based leveraging our current infrastructure, which is primarily, hosted on Bitbucket. We use a lot of pipelines to kind of get through stuff. So we have so many microservices. We kind of had to develop an interesting way where we couldn't necessarily sidecar particular projects, sidecar automation on projects. So this was basically a small solution a small example of a solution that we brought up. As you see, you have Mr. Joe developer over here. He's ready. He's confident. He's going to commit to the feature branch. We go through the flow, yada, yada, yada. And then we eventually deploy to our AWS environments.
So, we'll talk about like how this virtual test agent came about, but it's really a combination of these two things that we developed, right? And we were able to develop this with a very small team by leveraging services in AWS. Like we don't manage containers, we use ECS, right? We don't manage databases, we have RDS. Like the time not spent doing these things is time spent doing important things in the business, solving meaningful business sort of things. So we combine these ideas, and this is sort of what it looks like, right? Now we have end-to-end testing. We can come in and we can deploy web changes, OMM changes, updates to games, and we can test an event effectively end-to-end, an online or in-person event. We have standard testing, regression. We capture the results. We can measure success and failure. It can be scheduled anytime. We can run a bunch of different testing cycles or testing scenarios. Yeah, right.
Yeah.
That we can, and all this is programmatically defined. So this is really what it looks like.
Yeah. So this is kind of a low-res picture, but basically what we built was an orchestration layer over the spectator client framework. That's basically a data-driven framework. So we reduced the human being down to a very, very small data set, which is basically just like a username and password for our site and whatever game they want to play. And we feed this into our framework, the virtual test agent framework, and then we just simply pass tests against it based on whatever programming that we're providing. So, for example, if we have in this case, a League of Legends 5v5 tournament that requires at least one team to win, we can easily programmatically define that and kick this whole thing off, run a test, push button, and get results in about 45 minutes to an hour, whereas previously, we would literally have to shut down the whole office and hire a bunch of discombobulated cats to come in and try to do these things, right?
So we can set these tests. We can set different conditions. Like, what if somebody comes to the OMM, they don't confirm, or we have more people or less people? What if we want a particular person to win a game, or we've evolved it to the point where they can score specific objections, and so we can have a high confidence that when we get data back from these games about what happened, we can validate our stats and aggregation and all this leaderboards and all this other stuff. So this is we're going to do a demo. We spun up 4 of these virtual test agents, each denoted by this box. They're actually running their own instances, and we just combine the effective video output so you can see them all running concurrently. And so what this test is these 4 people will sign into our website, go through our OMM process, queue for a game, play a game. This is about an hour and 15-minute test or something like that. We've cut it down to about 4.5 minutes. But you'll see them go through this process. You'll see them play the virtual test agents actually fight each other because we need them to kill minions in League of Legends and other heroes and stuff like that. And then they stop and, it's part of this test. They stop and say, well, after 15 minutes, what do you want us to do? And we tell one group to surrender, and they do. And we generate a result.
Yeah. So this is Selenium. I'm sure everybody's seen it. Obviously, it's not in headless. But basically what's happening right now is we have a bunch of players that are acting like humans. They're going to our website. They have purchased a ticket. They have opened up the online matchmaking. They're all syncing up, coordinating player 1, player 2, player 3, player 4 to generate this tournament code right here. So the framework basically waits for the tournament code, sets it in a central data store, and then it will open up the League of Legends client and sign in with each unique player, and then play a game.
So this goes through a stepped process defined by the test. If it fails at any point, we can record video or capture screenshots of this. Nobody has to watch this happen, right? We're doing this so you guys can kind of see what it looks like. But realistically, this runs. You do a build that runs a test, the test completes, we get information back from the test, just like you would expect, right?
Totally, yeah. And we can implement this in any stage of the deployment pipeline. So if we modify some portion of the OMM that may kind of skew things in such a way that we're losing confidence, we can just toss this in as a step in our pipeline YAML and get some results, whether or not that change had an actual impact, a meaningful impact to our whatever thing we want within an hour and a half.
Okay.
Whereas previous to that, it would take a day.
And also we can scale this out, right? So we can do a test with 4 people, we can do a test with 200 people, whatever it requires, right? And we're effectively spinning this up and spinning it down, so we're paying just for what we use, and we don't have to go out and acquire 200 gaming machines to test 200 people or whatever we need, right?
Yeah, it's all based on this immutable infrastructure that Aaron built on top of leveraging AWS. So making this happen normally without AWS and the work that Aaron did would probably take me a year. This took me about a week and a half, 2 weeks collectively to kind of throw all this stuff together. And this will hypothetically work for literally any program or game that you can run on a machine. So if you have a heavy reliance on manual testing or very large group testing, qualitative testing, that just by leveraging some pretty common technology in Amazon Web Services, you can solve a lot of pretty cool problems with
Yeah.
parallelization and uniqueness.
So we didn't set out to solve this issue particularly, but we built stuff in such a way as it was extendable and consumable by other people. When we came with a problem, we looked and saw what was solved and what needed to be solved, and we leveraged solved technologies. Particularly, if Amazon had a solved technology, we would implement that, right, to save time to get to the business. As you can see, like one of the clients kind of craps out, and we actually recover from that. So it's
So
actually watching what's going on. It's pretty.
There's constant state updates that are being returned from the things that are happening. So we can, create these simpler handler processes that just kind of detect these state changes and will react based on those state changes, make decisions in a sense to keep the game rolling and allow us to get the results we need with very little actual human intervention. So everything's pretty much push button. As you saw, this client recovered, and it's going to go about on its merry way.